Hi everyone, this is Dr. Swaminathan SM. Now I am going to discuss about the topic called Routh Hurwitz criterion. It is came under the unit of stability analysis. So first review about the previous class. Last class we discussed about the stability types, and now introduction about the Routh Hurwitz criterion and conditions and the Routh table, and follow with the special cases and how to find the stability for the two different cases. So first thing, Routh Hurwitz stability criterion, it is a condition to satisfy the stability conditions. So the control conditions that stability condition must be necessary to find whether the system is stable or not. So first thing, the coefficients, that is a naught s power n. So first thing, you just look at this a naught, a1, a2 up to an. So the suffix that is called increased, and again s power n minus 1, that is decreased, is equal to 0. So this is called the characteristic equation. The roots of the characteristic equation should have the negative real parts, and the necessary condition is that the coefficient of the characteristic polynomial that must be positive. So these are all the two important conditions for the Routh Hurwitz. And then again, the important conditions, that is first column of the Routh array, that is must be in the same sign, then only the system is said to be stable, otherwise the system is said to be unstable. So look at this s power n. So s power n means first row, look at this a0, a2, a4, a6, that is the even side, that is even coefficient. And next s power n minus 1, that is odd one, means a1, a3, a5, a7. Next thing, s power n minus 2, look at this p1 means the first column is always constant. So a1, a2 minus a3, a0 divided by the first column, that is a1. And the next means a1, a4, that is first column and third column, a1, a4 minus a5, a0 divided by a1. And same thing for b3, and next c1, c2, like things. So s power 1 and s power 0. And the small activity for you, what are the right 5 letters become shorter when you add the 2 letters to it, that is short. What number comes to next that numbers 2, 4, 8, 10, 20, and what can you add to 11 and get 1 as the correct answer. If you wrote all the numbers 300, then what is the number written 3? So these are all the answer short, and again the 22. And when you add this 11 o'clock, then you can get 1 o'clock, and 120 times the 3 numbers came. So these are all the answers for the activity. And next, the special case of the Routh array, the first elements of any row of the Routh array is 0, then you can make the auxiliary equations from the non-zero value. So you can find, and again based on the auxiliary equations, you can differentiate and equate to 0. Then you can mention that array column that is replaced with the 0 into any numbers, then you can find automatically. So these are all the special cases for the Routh array. So we will see the examples. All the elements of any row of the Routh array are 0. Write the auxiliary equation that's above the row of zeros, and differentiate the auxiliary equation with respect to s. Then fill the number rows of zeros and with these coefficients. And these are all the how to find the stability, that is s power 4 plus 3s cube plus 3s squared plus 2s plus 1 equal to 0. S power 4, s power 3, s power 2, s power 1 and s power 0. Same thing. You look at this s power 4 means that is the even number 1, and the s square coefficient 3, and s power 0, that is 1. So if anything not available means you can consider s power 0. So anything power 0, that is equal to 1. So first row, that is even number, and second row, that will be odd number. Then you can make this regular multiplication, that is like first row, first column is common thing, and based on this you can multiply, and with this you can find up to s power 0. So there is no sign changes. So if there is no sign changes means, then you can consider the system is stable. And next, How to find the stable? So first thing, with this example, you can consider s power cube, that is 2 means divided by 2, you can commonly divided, then you can get 1 1. So if two things are all the things are 1 1 means, then you can get the 0 value. So the 0 came means we will go to the special case condition. So you take these auxiliary equations, that is the first column. So you can make this column is sigma, that is epsilon in the s power square coefficient. Then you make this s power naught and verify the sufficient condition for the Routh table algorithm. Then you can get this at sigma tends to 0, then youth array like this. So s power 1 is infinitive and s power naught is equal to 1. So if the condition is changed, that is first thing is 0 and again minus comes and again 1. So the system is first column is sign, that is first column sign is changed, then it is said to be unstable. So this is conditions. So this is another case you can find based on this. If the two cases are came to 0, then you can make the previous one, that is auxiliary equations a of s is equal to s power 4 plus s squared equal plus 1. So look at this, s power 4 means if you look at this second row, 1 means that is s power 4, another one means s square. So s power 4 plus s square plus 1 equal to, that is equal to a of s. A of s means nothing but auxiliary equation. Then again you differentiate the auxiliary equation with respect to s, then you can get 4s cube plus 2s. So you can consider s power cube and s power 1 values are came, that is odd numbers came. So you can mention 4 2, then divided by 2, that is 2 and 1, and make this regular column. Then you can get s power 1 coefficient, look at this, minus 3. So you can say the first column is sign changed, so the system is said to be unstable. So this is the stability conditions for the Routh array Hurwitz criterion. Thank you.